In the first part of the module on the Analysis tab, we provided generic information about the interface and showed you how to use its most basic features. In the second part, we're going to focus on the advanced functions. The four components we want to cover are Machines, No Runs, Unlinked Runs, and the Jobstream context menu. Machines provides immediate access to historical Jobstream records and individual component jobs running in parallel on a given system, something that's usually quite difficult to uncover with traditional tools. No Run shows the set of jobs that were expected to run based on the Jobstream definition extracted from the scheduler, but never materialized. Again, useful information because it points to a possible failure to execute or complete in the scheduler. Unlinked is the opposite function. AI has a process definition, expects a set of executions as a result, but captures more than that. Jobstream component parts not expected to execute create run records, which could point to some flawed definition in the scheduler. Finally, we'll discuss the Jobstream context menu, in other words, the set of actions an AI analyst can perform in the Analysis tab. AI's Machines module is an extremely useful function in the solution. It's a cross-reference tool between the Jobstream and the systems on which it runs. We're able to display the active load on the systems where the Jobstream is executed. Machines displays the entire list of jobs unrelated to the Jobstream but running concurrently. You can inventory the entire list of jobs running at the same time as the Jobstream, and even drill down into individual slices of time within the Jobstream to zero in on the specific time frame. If a Jobstream ran 2 weeks ago between 2 p.m. and 4 p.m., you'll be able to isolate a smaller slice of that time frame, say between 2:15 and 2:30, and determine what else ran on the system during that time. This type of information is very difficult to find in the scheduler itself or in other more conventional IT ops tools. Schedulers are able to report on this data in real time, say at 2 p.m. They will tell you what is currently executing concurrently, but they won't provide a historical perspective on concurrent executions on a given system. AI does this natively, and the interface is even multi-platform. If a job stream is spread across several systems, all of those systems are included and accessible through a single unified view. Let's use an example. We have two systems, 1 and 2. We have a job stream X with 5 jobs, with individual job parts spread across these two systems. Machines lets you select either system and a specific slice of time within the job stream run. AI will show you everything else that ran during that time. We briefly mentioned this in part 1. There's a second row of buttons below the main sets. One of these functions will display virtual resource conditions, as long as your job streams use this type of conditioning. If they don't, then the button is not there. The Machines button is always there. We have a job stream called cross-platform running with job components spread across two systems. Machines shows the 2 target agents with the relative loads for each. You can right-click on either blue bar and you'll be able to access the entire list of jobs running at the same time as this cross-platform job stream. But AI goes a step further. It's possible to show selective slices of time within that job stream. For this, we activate the interval button. Interval places a yellow box over the machine's progress bar. When you display the list of concurrent jobs in the machine details, it will be for that narrowed time frame. The left tab of Machine Details shows the machine itself. We click on the Jobs tab. We're able to see the entire list of concurrent jobs for the system executing during the entire job stream run, but we also have the option of displaying the narrowed time frame defined as the highlighted span. At the bottom, you see the concurrent executions. The jobs are listed along with their parentage, which means you'll be able to determine what else is running during this time, as well as the parent process. Jobs with partial overlap are in regular fonts. The selected job in the job stream is italicized, and jobs in bold start and end inside of the selected job's runtime. By selecting the highlighted span, you report on a narrower, more focused list of jobs overlapping with this job specifically, as opposed to the entire job stream. You can narrow it even further by placing a time marker inside the highlighted area. AI will then report on the same data points for that specific point in time. The Machines module is valuable to anyone handling systems and applications who worry about overall workload, sysadmins, DBAs, even network administrators. And remember, The true power of the feature stems from the fact that this isn't only real time. You can go back over years of historical records to obtain this information. Let's select another time frame. The purpose of the no runs function is to uncover possible misbehaviors in the scheduler. At some point in the past, we created a job stream for a process in the scheduler, and AI obtained the definition as a result. If that definition contains X number of component jobs, then AI expects to see a matching number of jobs, X, running for that job stream. If certain jobs withhold execution, then AI reports these as no runs. In many instances, these are normal behaviors. That particular job is part of a process, but runs on a different schedule from the parent process, and so the no run can be ignored. But in other cases, the no run might indicate an abnormal behavior. Using this AI function, job owners can quickly and easily identify these behaviors and fix them as needed. Let's use an example of a normal behavior to show how the function works. We have a workflow with 3 jobs. The process runs every day. But the first job has a calendar condition Mondays only. From an operational standpoint, this means the process executes every day, but only the second and third job. On Mondays, all 3 executes. On all days except Mondays, AI reports the first job as a no run. Let's show what this looks like in AI. We've recreated the process we just described. The 2 jobs ran as expected. If we display no runs, we see the first job as well. The unlinked run function is basically the opposite of no runs. AI does not expect an execution but captures one during the Jobstream run. This type of information is useful for somewhat similar reasons. AI captures the definition, expects a set number of component job runs, but gets more. Unlinked runs can uncover instances of job runs that aren't supposed to be there. A good example is a process that executes once a day, and an operator is instructed by a job owner to run one of the component jobs manually with no regard for the overall integrity of the application. The operator runs those additional instances and AI flags them as unlinked runs. If integrity issues occur at some point in the future, the organization will be in a position to revisit past Jobstream runs and see those unlinked runs as a possible root cause for whatever problem they have to resolve. This is what the example shows. We have a process with 5 individual jobs, and the last one was submitted twice during the Jobstream run. AI sees these runs as component parts of the parent process that aren't supposed to be there. Let's look at the Analysis tab. We have a Jobstream run, and we ran an additional instance of the last job once. We click the Unlinked Runs button. Finally, let's consider the Context menu. To access this menu, we right-click on a job stream. This enables a set of capabilities and actions that are important for the analyst. We right-click on a job stream or just a job. We're already familiar with many of these, or we'll learn about them in future modules. We've covered job details and the icon helper. We've seen the settings and the expand and navigation tools. In the functions at the bottom of the menu, we're able to copy the name of the selected object and create a new job stream directly in the business area. We can manage trim points and start job entries, which we cover elsewhere. Finally, we have the predicted duration. Predicted calculations are automated in AI. Jobstream run and runtime data is collected over time, which AI uses to build predictive models. This being said, if you're not comfortable with a prediction for a particular job stream because you're aware of outside facts that may impact runtimes in the future, you can override the automated prediction and set your own. In the real world, this might be true when we're aware of workload being added to an application, which is going to slow batch activity as a result. You can estimate the impact of the slowdown and factor it in extending your predictions for this job stream. If these changes are temporary, then you can also provide expiration information, at which time AI will revert to automated values. Finally, we wanted to add a quick note on the critical path. This is the stream of critical jobs that must complete in order for the overall process to be deemed successful. In the job stream, those jobs appear in the red color, while jobs that do not belong to this critical path are purple. The establishing of the critical path of a job stream is the result of automated and perpetual analysis by AI based on the target job and the behavior of its predecessors. It looks at several factors and determines which jobs are critical to process completion and which aren't. The critical path will evolve over time on the basis of new executions and fluctuations in predecessor behavior.